Hello everybody, welcome to next part about resistors. In this part we're gonna talk about types of resistors, their compositions and how to read their values. Resistors come in a variety of shapes and sizes. The first major categories into which the different types of resistor can be fitted is their packaging. There are three main categories for packaging. The first category is through-hole resistor or THD resistor. THD stands for through-hole devices. They are resistors with two leads that can be put through holes on a circuit board. The next category is chassis mount resistors. They are resistors in a metal or ceramic case that can be mounted to a structure to help dissipate heat. The next category is surface mount resistor or SMD. They are a smaller rectangular shaped resistor that can be soldered to the surface of the circuit board. As you can see in the right picture, they are soldered on top of the circuit board. The second major resistors categories is their value. They might be a standard static resistor, a pack of resistors, or a special variable resistor. The first category is fixed resistors. Fixed resistors are the most widely used types of resistor. They are used in electronic circuits to set the right conditions in a circuit. Their values are determined during the design phase, and they should never need to be changed to adjust the circuit. The next category is variable resistors. Variable resistors are resistors which can be adjusted between a specific range of values. Variable resistors connect two resistors internally in series and adjust the center tap between them, creating an adjustable voltage divider. When a variable resistor is used as a potential divider by using three terminals, it is called a potentiometer. When only two terminals are used, it functions as a variable resistance and is called a rheostat. Also, electronically controlled variable resistor exists, which can be controlled electronically instead of by mechanical action. These resistors are called digital potentiometer. Also, there are another types of variable resistors that their value change by environment parameters like light, temperature, and voltage. One of them is light dependent resistor or LDR that sometimes is called photoresistor. LDRs change their resistance with the level of light. They are used in many sensor applications and provide a very cost-effective solution in many instances. Another case is thermistor. As the name indicates, thermistors are heat-sensitive resistors. The resistance of the thermistor varying with temperature. Some of them have a negative temperature coefficient and the resistance decreases as the temperature increases, named NTC, and others have a positive temperature coefficient, named PTC. The next case is varistor or VDR, that stands for voltage dependent resistor. Varistors are available in number of forms. Essentially, these electronic components vary their resistance with the applied voltage, and as a result, they find uses for spikes and surge protection. The last category is resistor array. A resistor array or resistor network is a single package that contains two or more resistors. The package will include multiple leads by which the network can be made part of a larger net circuit. The main advantage of resistor network is space and time. When using the same value resistor multiple times, as in pull-up resistor or a microprocessor bus, placing one component that has say 8 resistors in it with no space between them, it saves more space. We talked about pull-up and pull-down resistors in previous part. Resistors are also classified according to what the active material is made of. The first material is carbon composition. Carbon composition resistors consist of a solid cylindrical resistive element made from a mixture of finely ground carbon and insulating material. The mixture is held together by resin and wires, or either embedded in the ends, or a thin metal cap and wire is attached to each end. The resistance is determined by the ratio of the powdered ceramic and the carbon. The next material is carbon film. In this case, a spiral is used to increase the length and decrease the width of the film, which increases the resistance. Varying spiral shapes are used to create a variety of resistance. The next material is metal oxide film. This type of resistor is now the most widely used form of resistor. Rather than using a carbon film, this resistor type uses a metal oxide film deposited on a ceramic rod. As with the carbon film, the resistance can be adjusted by cutting a helical groove in the film. The film is protected using a conformal epoxy coating. This type of resistors can be supplied to a much closer tolerance, 5% or even 2%, being standard with 1% version available. Next material is metal film resistor. The metal film resistor is very similar to the metal oxide film resistor. Visually, it's very similar, and the performance is also comparable. Instead of using a metal oxide film, this type of resistor uses a metal film. Metals such as nickel alloy may be used. Metal film resistor is available in thick and thin film versions. Most SMD resistors are of this type. The principal difference between thin film and thick film resistors is how the film is applied to the surface. Thick film resistors are cheaper and less precise than thin film resistors. The next is wire wound resistors. This resistor type is generally reserved for high power applications. These resistors are made by winding wires with a higher than normal resistance on a former. And the last one is foil resistor. Foil resistors have had the best precision and stability ever since they were introduced. Advantages of foil resistor are high stability, low noise, low capacitance, and low inductance. In this part, we will find out how to read resistors value. Through-hole axial resistors usually use the color band system to display their value. Most of these resistors will have 4 bands of color circling the resistor, though you will also find 5-band and 6-band resistors. In the standard 4-band resistors, the first 2 bands indicate the most significant digits of the resistor value. The third band is a weight value, which multiplies the 2 significant digits by a power of 10. The final band indicates the tolerance of the resistor. The tolerance explains how much more or less the actual resistance of the resistor can be, compared to what its nominal value is. For example, in our case, first resistor has 4-band color code. First band is brown, so the first digit will be 1. The second band is black, so the second digit will be 0. Placing together these 2 digits will result 10. The third band, which is the multiplier, is orange, so the multiplier will be 1000. So the final value will be equal to 10 multiplied by 1000, which is equal to 10,000 or 10 kilo ohm. The last band indicates the tolerance. In our case, it is gold that indicates that our actual value will be around 5% of its value more or less. 5% of 10 kilo is 500 ohm. So our actual value will be something between 9,500 ohm to 10,500 ohm. 5-band resistors have a third significant digit band between the first two bands and the multiplier band. 5-band resistors also have a wider range of tolerance available. The second resistor in our example has 5-band color code. First band is yellow, so first digit is 4. Second band is violet, which is 7. Third band is green, which is 5. And the fourth band is red, which is the multiplier and is 100. So the final value will be equal to 475 multiplied by 100, which is equal to 47.5 kilo. And the last band represents resistor tolerance. In our case, it's brown, so its tolerance will be 1%. 6-band resistors are basically 5-band resistors with an additional band at the end that indicates the temperature coefficient. This indicates the expected change in resistor value as the temperature change in degrees Celsius. In our case, it's brown, so from this table, our temperature coefficient will be 100 ppm. Thank you for watching this video. Please subscribe to my channel and like the video if it was useful for you. I will see you in next video.